Hello, welcome to my Pre-Algebra review series. This video covers Chapter 3, Section 3, titled Mean, Median, and Mode. By the end of this video, you will have reviewed the processes for finding the mean, the median, and the mode, including procedures for choosing the best measure to solve the problems being investigated. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's get into it. Okay, definitions. Measure of central tendency. Mean, median, and mode are measures of central tendency of a collection of data. Consider the data 2, 3, 4, 5, 8, 8, and 12. The mean is the sum of the data values divided by the number of data values, which in this case happens to be 7 data values. The median is the middle number when the data values are written in order and there are an odd number of data values. For an even number of data values, the median is the mean of the two middle numbers. Mode. The mode is the data item that occurs most often. There can be one mode, more than one mode, or no mode values. We'll address these as we move forward for sure. Objective 1, finding the mean, median, and mode. Measures of central tendency. The mean, median, and mode are measures of central tendency of a collection of data values. Consider the data 2, 3, 4, 5, 8, 8, and 12. That's here 2 through 12. The mean is the sum of the data values, that's the 1, 2, 3, 4, 5, 8, 8, and 12, those are the data values, divided by the number of data values. So we'll add up all the number values, all of the data values, and we come up with, as it shows here for the mean, you come up with 42. Okay? And then you count the data values. How many? The number of data values is 1, 2, 3, 4, 5, 6, 7. Here it is, divided by 7. Divided by 7. 42 divided by 7 is 6. The mean of this data collection is 6. So let's look at the median. The median is the middle number of the data values. When the data values are written in order and there are an odd number of data values. For an even number of data values, the median is the mean of the two middle numbers. Okay? So in our case here, the median, 2, 3, 4, 5, 8, 8, 12. There are 3 numbers on one side and 3 on the other. That means that 5 is a middle value. So that's going with if the mean is the middle number, right, or the middle number, when the data values are written in order, and they're an odd number. And there are an odd number, 1, 2, 3, 4, 5, 6, 7. We know there's 7. So the median is 5. It's the middle number. It's that simple. 5 is the median. That's the median number. The mode. The mode is the data item that occurs most often. There can be one mode value. There can be more than one mode value, more than one, or there can be no mode values. In our case, the mode for our data set, 2, 3, 4, 5, 8, 8, and 12, the mode is 8. The mode is 8 because 8 occurs more often than any other number. That's what it says. The mode is the data item that occurs the most often. And right now, 8 occurs more often than any other numbers. Okay? Example 1, a real-world problem. Fundraising. 6 elementary students are participating in a 1-week readathon to raise money for a good cause. Use the chart to find the mean, median, and mode of this data set. Okay? So what is the mean? What did we say the mean was? The mean is the sum of the numbers 40, in this case 40, 45, 40, 45, 48, 50, 50, and 59. You add them all up. Okay, I want to do it. Let's see. Let's try it. Let's see. 40 plus 45 plus 48 plus 50 plus 50 and plus 59. And that equals, I've done it on the calculator ahead of time, and it's 292. Okay? And then the mean says add them all up and divide by the number of elements or values. 1, 2, 3, 4, 5, 6. There are 6. So we're going to divide by 6. And if you do that and divide by 6, the number ends up being 48.666. That is the mean of these numbers. So you just add them up and divide by the number and whatever it comes out to. Now, of course, if the problem instructs that you round to the nearest tenth or hundredth or units or whatever, you also have to do that. But right now, we stopped here at 48.666. The median. What is the median of this data set? Well, the median says it's the number that is in the middle, right? It's that they're looking for the exact middle, well, of the data set. So in our case, we have six numbers: 1, 2, 3, 4, 5, 6. That means that we're going to be in the middle. So since our data set is in order, all we have to do is go, in this case, 1, 2, 3, put a line there, 1, 2, 3. The middle is right here. Well, how does it say get the middle value, this median value? It says take the mean of the data item before and after. It's the two middle items. So if you take 48 and 50, so 48 plus 50 is equal to what? 98. And if you divide 98 by 2, your answer is going to be your answer is going to be 49. Okay? Mode. The mode says what value occurs most often. It doesn't matter where it is in the table. It could be at the very beginning, the very end, anywhere in the middle. What number? And it doesn't have to be, they're going to be next to each other because you put the data bytes in order. So you're going to find them. And in this case, the first set of like data we have is 50 and 50. Those are the two that they occur 2 times. Everything else occurs once. So the mode in our case is 50 because it occurs twice. Okay? Example 1, check your understanding. Find the mean, median, and mode of the data set 2.3, 4.3, 3.2, 2.9, 2.7, and 2.3. Okay, this is for you. This is your turn. Go off, stop the video, give it a shot. We're going to find the mean, the median, and the mode. When you come back, we'll do them together. Okay, now that you've done them on your own, let's give it a whirl. First, let's find the mean. MEAN, the mean. So what is the mean? Well, the mean is we're gonna take and add up these values, and then we're gonna add them up, and then we're gonna divide by the number of values, which is 6. So, but before we do it, add them up. In the process of adding them up, I'm going to write them in order too. So I'm going to take that little step ahead. So I'm going to say 2.3 plus, because we're going to add them, 2.3 plus, and then the next higher value is 2.7. 2.7 plus, next up is 2.9, 2.9 plus 3.2, 3.2 plus 4, the final number, 4.3. And all of that equals, when you add it all up on your calculator, which I did ahead of time because, as I've said before, I don't have a calculator I can pop up on the screen here. So I did it ahead of time, and the number turns out to be 17.7. And that's the sum of the numbers, and then they say divide that set of numbers by the number of occurrences, which is 6. So we take 17.7 and we divide it by 6, and we end up with the number of 2.95. There's the mean of this data. So now let's do the median. MEDIAN. The median is you take all of these numbers. Now they're in order. I put them in order so you don't have to look for it again. You already see them in order. And what you do is you look for, is it an even number or not? If it's an even number, you have to find the middle two values. Well, the middle 2 out of 6 happens to, here's 3. So the middle 2 happen to be right here in that space right there. And we're looking for the one right here in the middle. So what we're going to do is we're going to go ahead down here. We're going to say 27 or 2.7 plus 2.9. These are the two middle values. And we're going to find the mean of those. So there are 2 of them. We're going to divide by 2. Well, if we add these up, we're going to get 2 and 2 is 4, 7 and 9, 16. 4 and 16 is 5.6 divided by 2. And when we divide that by 2, we're going to get what? We're going to get 2.8 as our median. So that 2.8 fits right here in this little cubby hole right there. That's where you'd see it, right there. If it was there, it would be between those two right there. Now, next is the mode. M-O-D-E. The mode says, I want the value that occurs most often. It could happen one time, it could happen 3 times, it could happen no times. But if it happens, let's find it and list it off. So what is the mode? The mode in our case is, if you look at it, the only value in here that occurs more than once is 2.3. Those two numbers. None of the others occur more than once. So the mode of this collection of data is 2.3. It's that simple. Example 2, identify modes. This is the mode. All we're looking for in these 3 problems is the mode. So how many modes, if any, does each have? So let's look at them. So what is the mode? The mode is the values that occur more than once. Okay, and there can be more than one mode, or no modes. So let's look at this. The first one here is $1.50, $1.50, $2, $2 and a quarter, $2.40, $2.50, $3.50, and $4. Well, none of them repeat. So there are no modes in this example. None of them repeat. Okay? So B, let's go through this. 2, 3, 6, 8, 8. Okay, let's write this down. So 8, 8 is a mode. 10, 11, 12, 14, 14. 14 and 14 are modes. They're in order, so I know there are no other modes. The modes in this problem are 8 and 14. They both occur the same number of times. Okay? How about this one with they're not numbers anymore, they're fruit. So, grape, but right here. Grape and grape. There's a mode right there. Banana, nectarine, strawberry, strawberry, strawberry. Orange, watermelon, strawberry, strawberry, strawberry. Well, there are 2 grapes, but there are 3 strawberries. So the strawberries win because they are the most. You can have multiples of other numbers, but if it's not as many in the multiple as one lives. So strawberry is the winner. Okay, example 2, check your understanding. Find the number of modes in each of these 2 problems. So how many modes are in A and how many modes are in B? Go off on your own, do it, give it a shot. When you come back, we'll do them together. Okay, I'm assuming you've taken the time to do this. I'm hoping you did. Let's start problem A. So we have, first of all, we have to put these in order, don't we? Well, no, they don't. Really, we don't. Why don't we? because we're not trying to find the median. However, putting them in order really helps you find them. So I'll just take the time to do it, okay? So the lowest number here is 7. So we have 7, 7. The next number is obviously 8, 8. And we have a 9. There's only one 9. There's two 11s. 11, 11, and a 13. Did I get them all? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, which numbers are, what are the modes, if any, and what are they? Well, it's the numbers that occur the most times. And if there's multiple patterns that occur the same number of each time, then they're both considered mode. So in our case, the 7s are mode 7. The 8s occur twice. The 7s occur twice. 8s occur twice. The 8 are mode. Not the 9. The 11s are mode. And not the 13. There are 3 mode values. 3 modes. Okay? Does that make sense? Hopefully it does. Let's do B. 38.5, 55.4, 45.3, 38.5, and 68.4. Well, 68.4. Let's find them in order. Okay, we don't have to, but the lowest occurring value in here is 38.5. 38.5, comma 38.5, comma. Okay, the next after that is 43. 45.3, comma. Then we get 55, 55.4, 55.4, and then 68.4. Okay, what are the modes? Well, with 38.5 and 38.5, the other ones are not. There are no other multiples of anything. So there is one mode, 1, and that's 38.5. One mode. Okay? I hope that's helpful. Okay, example 3, a real world problem is an outlier. Is a data value that is much greater or less than the other data values. So it's an outlier way out. So if you had what numbers 10, 9, 7, 5, 11, 9, 8, and 23, oops, 23 is way outside the numbers that are closer to it, right? So it's called an outlier. Could be way less or way more. So that's what they're talking about. So the question here, which data value is an outlier? Well, when we look at these, we have the country and land mass. So we see here that it looks to me like Belize, 200 miles square. It's pretty small, Okay. That might be the outlier because all the rest, look at these, all other ones have thousands and 2,000s. So what others? If that's the smallest, then the next thing you ask yourself, what's the largest? And the largest number in here, if I look through them, appears to be maybe Honduras, 6,500 square miles or miles square. Yes, it is. So now the question you have to ask yourself, which one is farther from its next closest as a greater spread? Well, if I look at the Honduras compared to its next closest, which appears to be Guatemala, 6,500 minus 5,000 is 1,500. 1,500 miles square. That's what I see for the difference between Guatemala and Honduras. Now for the Belize, it's 200. What's the next closest to Belize? The next closest to Belize is 1,200. Well, 1,200 minus 200 is 1,000 miles square. So now you have to ask yourself, which one is farther out? Well, it looks like the Honduras is the outlier in this group. Okay, which data value is the outlier? I say Honduras. H-O-N-D-U-R-A-S. Honduras. Okay, so how does the outlier affect the mean? Then it says find the mean with and without the outlier. Well, the answer is how does it affect it? Is it drives the mean drastically further in one direction than the other. If I add like my original numbers 10, 9, 5, 6, and those numbers all averaged about 8, and I add 4 of them together, I have 32. Well, if one of those numbers was 20, that would take that 8, the average there, and it would drive it way high. It would drive it way high and make it, instead of 8 being the average, it might be 12 or 15, which would be really the wrong average because that outlier drove it in the too far away from the rest of the data points. So we're going to look at it. So it says find the mean with and without the outlier. So 21,700 divided by 7, which is the value of all of these. There's 1, 2, 3, 4, 5, 6, 7. So 21,700 is the sum of all of these miles squared. And that's, if you divide 21,700 by 7, you get 3,100. Now, if you take out the outlier, you're going to get 15,200 divided by 6, and the number is 2,500. Well, you see just that one took the average of all the other ones, which were 2,500. They are all 2,500, was the average of the 6 without the outlier. Add that one data point in it, and it jumps up 600 points. 600 miles square. It's bigger. The outlier caused a larger change than the amount Belize added all by itself. Okay, so we subtract 25 from 31, we get 600. The outlier does what? It vastly changes the mean. And it's the only one it bothers. It doesn't bother mode and median. I don't care where the outliers live. It's still going to be the data in the middle, the point in the middle, and it's also going to be of so many numbers, or it's going to be the amount of occurrences that are similar. And in our data right here, if you look over them, there's no mode in that data that we're looking at right now. Okay, now there'd be a median. We'd have to figure it out, but there's no mode. Okay. Okay, example 3, check your understanding directions. Find the outlier in each group of data below and tell how it affects the mean. Round to the nearest tenth. So it means like we're going to solve 2 sets of problems for each one, right? You're going to run a mean with the data and run the outlier and run a mean without the outlier and subtract them and find out what the difference. And then find out whether it raised it or lowered it and by how much to the nearest tenth. That's on both of these. So why don't you go off and do them? When you come back, we'll do them together. Okay, so we're going to assume you've done that. And what we're going to do now is see if we can solve this problem. Let's see. We're going to, I got to get my pencil here in my hand. Sorry. So in order, first of all, in problem A, we're going to look through these. What I like to do, I have to add these. I'm not going to add them twice. I'm going to add them one time. But I want to find the outlier. And the outlier appears to be, if you go through these points, they're all around 10, except for this one here, 31 is the outlier in this group. We can jump to this group too. We don't have to always do them together. This one, the outlier, these are in the high teens, appears to be the 1. So now that's behind us. So we're going to run the set of numbers. We're going to add all the numbers one time, and we're going to adding the numbers here on A for without the outlier. So we're going to get, I'm going to go ahead and I'm going to say 9 plus 10 plus 12 plus 13 plus 8 plus 9 plus 9, and that equals, and I've done that ahead of time, 70. And there are 1, 2, 3, 4, 5, 6, 7 items. So we're going to divide these 7 items by the value here by 7, and we're going to get 10. I think I have to start writing a little smaller. We're going to get 10. So now all we have to do is we have 70, and we're going to add the outlier, and the outlier is 31. So now we're going to say 70 plus 31 is 101 divided by 7 this time. 8 rather, excuse me. I thought it was 6 last time. Erase that. Divide it by, oh, come on, get my ink back, by 8. And 101 divided by 8 ends up being 12.6. 12.6. Well, if you take 12.6 and you subtract 10 from it, you get 2.6. And that's already pretty much rounded to the nearest tenth. That's what they said, to the nearest tenth. What did it do? The outlier, this 31 outlier, raised our average, because our average here was 10, and here, or the mean, and the mean here was 12.6. So it raised it by almost by 2.5, 2.6 points. That's quite a bit. Okay, so it raised it, and that was it. And 31 is our outlier. We added that. Now, if we go over here to this other one, we already determined that 1 was the outlier, and we're going to add 17.5 plus 18 plus, what do we have? 19.5 plus 16 plus 17.5. Okay, 17.5. And if we add them all up, we're going to end up getting what number? We're going to get 88.5. And the number that we have to add also is the outlier. So we're going to take 88.5 plus 1 is equal to 89.5. And what do we do with 88.5? We're going to divide it by 1, 2, 3, 4, 5. 88.5 divided by 5 gives us 17.7. And if we take 89.5 and divide it by 6, one more, and we look at that one, we're going to get 14. See, look at that, 14.916. But I'm just going to say 0.9. That's rounded to 0.9. Excuse me. So there we have the value did what? When we added the outlier, it drove our value down. It decreased our average by quite a bit. Quite a bit. Almost 3 full points. How much was it? Well, 17 minus 14 is 3. Okay. But let's look at it this way. 17.7, 14.9, when we subtract these two, we're going to end up getting 2.8. Okay. 2.8. Well, the average here, the difference is what I meant to say, excuse me, is quite a large number. It's almost 3 out of an average before that, which was 17 or 18, which is it's a big change. So there you have it. This one is the outlier, wherever the 1 went. Oh, it's up here. 1 was the outlier. And it lowered the value, and the difference was 2.8, that it lowered it. Okay, objective 2, choosing the best measure. One measure of central tendency may be better than another to describe the data. For example, consider the 8 hourly wage rates shown below. Here are the measures of central tendency. The mode of those 8 values is 550. Look at, there are 3 of them. I'm going to mark them. For the mode, there's this one, and this one. There's 3 values. 550 is occurred most often. The mean, which is, as we like to say, the average, you add all 8 of these up, and then divide by 8, and you're going to get 750. Okay, and we can look in here later where 750 lives, but 750 is going to live somewhere between these two right here. It lives somewhere in there. Okay, and then the median, which is the number that's right in the middle. And the number right in the middle is, well, you've got 8 values, so it has to be right here between these two, between the 6 and the 620. Well, you can tell just by looking at it that the middle of that value is $6.10. Okay, so there they are, 550, 750, and 610. The mode is the lowest wage listed, happens to be the lowest wage, right? The mode does not describe the data very well. When you look at all 8 values, 3 people are making 550, but the rest of them are making more than that. Not considerably more, but a better salary. The mean is above the hourly average, so the mean is 750. But if you add that's what this is. For all but 2 workers. Okay, so if you take the mean 750 and you look, the mean is above every one of these 6 values. I'm going to go from here. I'm going to change my color to red. So the mean is going to go and pick up all of these, and it's going to slip through here. So that's what they're saying, that the mean that is between all of these numbers and these 2 over here. It's somewhere between $6.30 and $8, which is $7.50. So it's sitting right in there somewhere in that middle. And then it says the median has the best measure of central tendency here, since it is not influenced by the size of the outliers. And the outliers are going to be, well, this $17 is an outlier, right? All of these are like $6, $7, $8, and all of a sudden, oops, $17. Whoa, where did he come from? That's an outlier. That's what an outlier is. So the median is not influenced by that. So probably the best measure of tendency is 750. And if you look at these, the median is probably 610. Yeah, it's up into here somewhere, 620, right in here between the 6 and the 620. So there are 4 above it, 4 below it. It probably best describes what's going on in the pay. This isn't a perfect science. It's a guessing game, but it looks close. Okay, example 4, identifying the best measure. So, which measure of central tendency best describes each situation? And then explain. So the question here says, the favorite movies of the children in the 8th grade. So if you had mean, mode, and median to try to just say, which is the favorite movie? How would you do it? Can you average movies together? Probably not. Can you find the middle movie of 8 or 9 different movies or 20 different movies? Can't do that. But you can do what? You can look for the mode. So I would say that the mode best describes it, because if I have 4 movie A's and 4 kids liked A better, and B was liked by 2 kids, and C was liked by 5 kids, whatever, right? Then we would go and say, well, and this was it, 3 movies. Then you say, well, it appears here that the most children watched C, 5 children. 2 of them watched B, 4 of them watched A, but 5 of them watched C. So chances are that the C movie was the favorite amongst them. Seems that way. How about B, the daily high temperatures during a week in July? Well, if you take all of what are the daily high temperatures? Starts out in the morning at 60 degrees, goes up to 80 or 85 or whatever in the afternoon, and then drops back down to 50 something. Those are the highs. Well, the daily highs is you look at all 7 days of the week and you take the high value. Well, how do you define that value? Well, what's the best way? If I say, well, I'd probably say I don't want to know the middle value, because that's not going to allow me with outliers. You could have 5 days at 60 degrees, 6 days at 60 degrees, and 1 day at 100 degrees. And that 1 degree that outlier is like way out, right? So it's not going to help you understand what the general temperature was during the week. In this case, chances are that the mean is the best way, because you just take all the numbers, you add them up, and you say, oh, it was 75 today and 73 yesterday and blah, 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 blah. When you're done with all 7 values, you end up with a 77 divided by whatever, you know, and then you get the answer. So the mean is probably best fits that. And how about the distance the students in your class travel to school? Well, is it the average distance? Well, it could be the average distance. But does that account for outliers? What if everybody lives around the school, like I remember the schools, around the high school, the elementary schools especially. Every kid lives within maybe a mile of the elementary school, at least in the bigger suburban areas that way, and urban areas. But there may be one child that has to be driven in from 8 miles out because there's no other school, or so that one outlier there is going to change the value. So as the distance students in your class travel to school. So probably the best thing to do there is the median. The outlier can affect the mean because you're not using the outlier. And the mode, there's not how many days, if 4 of the kids all travel exactly 4 miles or excuse me, a quarter mile, it's not really going to help us. What we really want is the middle number. If you take all the numbers and it's the middle number. So I'm going to say that that's probably half of the kids travel less than this, half the kids travel farther than this amount. So that's a good representation. They all are about 3/4 of a mile. Half of them are under 3/4, half are over 3/4. And that one outlier, way out there, 7 miles out, doesn't really hurt that middle value that much. So I'm going to say for C that the median is the value. Okay, example 4, check your understanding. Determine the central tendencies. So they want us to find all the values, the mean, the median, and the mode of these shirts that Toshio found, these sports shirts at different prices, ranging from $18 to $42. 8 different shirt prices. So you go off, do them, calculate the mean, the median, and mode. Try to answer the question B, see what you come up with there. And come on back and we'll do them together. Okay, now that you're back, let's go ahead and give them a shot. So the first thing I'm going to do is I'm going to try to find the mean. Mean, M-E-A-N. And to find the mean, you have to add all the numbers together. And you have to divide by the number count, which in our case is 8. Well, if you add the numbers together, I'm going to put them in order because eventually, after I put them in order, for the median, since I know I have to calculate it, they have to be in order. So I might as well just put them in order right now. So I'm going to start off with 18, and then I'm going to do a 20, and plus another 20. I'm adding them, 20, 20, and then after that is a 21, plus 21. And from the 21, I jump to a 26, plus 26, plus then from 26, I jump to a 27, and then plus 28, and plus, after the 28, there is no 29, or there are no 30s. We have a 42. And we know that there are 8 of them, and we know we're going to divide it. So we're going to divide these numbers by 8. And when we do that, since you know I don't have a calculator I can pop up, I've done the math already. And the math ends up being 202, if you add them up, over, and we're going to write them over 8. And when you do that division, you're going to come up with $25.25 is the average price of those shirts, the mean price, $25.25. Okay, so now we're going to do the median, M-E-D-I-A-N. The median value. How do we find the median value? Well, if it's an odd number of values, you take the middle value. Ours are all in order. You have to put them in order first. And ours is even, so we have to pick the average of the middle 2. So we find the middle 2. So I'm going to count, there's 8. So 1, 2, 3, 4 right here. And there's 8 over here. Starting at the 26 over here. So the middle, I'm going to change to red. The middle is somewhere in between here. Between 21 and 26. Well, what is that value? Well, we know that it is 21. It's the average of those, the mean, plus 26 divided by 2. And 21 plus 26 is what? 47 divided by 2. And 47 divided by 42 is, by 2 is 23.5. So the median is 23.5. Next, we find the mode. I'm going to do that in blue. Mode. Well, first I'll write it in yellow. Mode. Oh, didn't change. Come on. I pushed you. Mode. Okay, what is the mode? The mode is the number with the highest occurrence. There might not be one, but if there are numbers that occurred more than once, those are a tendency to be modes. There could be different modes and there could be different numbers of modes. But right now, in this example, there are only two numbers. And I mean, one number actually. It's these two here, two values have a value of 20. So in this case, 20 is our mode. Okay? 25, 25, 23, 50, and 20. So now we have that. So it says, which measure of central tendency best describes the data? Justify your reasoning. Well, we know from previously when we were studying this section and reviewing this section, we found that the mean is most affected by outliers. So if our data has an outlier, either large or small, that can affect our central tendency figure that we're looking for in an adverse way, affect it adversely. And if we look through our data, we know that we have an adverse data item, and it's this 42, because it is an outlier, and it's, I mean, if you look at these numbers here, they're all near 25. 42 is almost twice that much, so you know that's going to affect the average. It won't affect the median, it won't affect the mode, but it certainly affects the average. So it's probably going to have a tendency to disturb our results when we're trying to find the best fit central tendency. So then we go to the median. Well, the median says pick the two middle values. The two middle values are 23.5. Well, the median could very well be the number we're looking for. Could it be the mode? The mode is 20. Well, the mode sits way at the bottom down here, and we know that the average is 25, which jacked up a little bit because of the 42. We know that the median is 23.5, and since the mode is 20, that's quite a bit below the 23.5. So it seems to me that the middle value is here in around 23, 24. 20 is going to be too low, so it's probably going to be the median. That'll give us the best answer. So if you look at this group as a whole, the prices range somewhere in the middle 20s. That's kind of what you're going to shoot for, and that's why this median is best. So anyway, if you wanted to take a look at, here's something we could take a look at. What if we took the median and wanted to look at this outlier? How much did it really affect us? And is that now closer to the median value? The one we picked is the better number. How close are we to the median value if we remove like that outlier that we talked about, getting rid of the outlier previously? Well, if we take all of this, we say 202, and we subtract 42, we're going to get 160. Well, if we take 160 now and divide 160 by 7, not 8, by 7, all right, what are we going to get? Well, 160 divided by 7 ends up being 22 something. Well, there it is. It's pretty close to that median value.